7.5, we're going to be solving rational equations. So equations means that we're going to have an equal sign. Whereas yesterday we were simplifying rational expressions. Notice how yesterday we didn't have an equal sign. We had just added them or subtracted them, but our answer is still a fraction. Here we're going to have x is equal to. We're actually solving all the way to x because we'll have that equal to sign in our equation. So there's two different ways that we're going to be solving rational equations. The first one is when we have a fraction is equal to a fraction, we can cross multiply. So cross multiply, it means that we multiply the bottom of one to the top of the other, and the bottom of the other fraction to the top of the other one. So exactly what it looks like, we're cross multiplying. So here I have 3 times 4x plus 5 is equal to, that equal to sign stays in the middle, and then 9 times x plus 1. So by cross multiplying, we get rid of the fractions, so we don't really need to worry about them anymore. Here we just solve like we normally would. What would I do next to solve for x? Distribute. So I can distribute the 3 and distribute the 9. So this gives me 12x plus 15 is equal to 9x plus 9. So then we can just combine our like terms together. So I'm going to move the 9x to the other side and subtract 15. Let's move our x's to one side, the constants to the other. So that gives me 3x is equal to 9 minus 15, which is negative 6. Then what do I do next? Divide by 3. So what does x equal? Negative 2. All right, let's look at the next page. So here we've got 3 more that we're doing the same thing. We are cross multiplying. So you can always do this when you have a fraction is equal to a fraction. Just one fraction on each side. So we can cross multiply. So I have 3 times x minus 7 is equal to 2 times 5x. What would I do next? Distribute. So I have 3x minus 21 is equal to what? 10x. Perfect. I'm going to move the 3x to the other side, so I'm going to subtract the 3x. So I have negative 21 is equal to 7x, and then what's the last step? Divide by 7. So what does x equal? Negative 3. Perfect. Let's look at 2. What's the first thing I should do for number 2? Cross multiply. So we have negative 4 times x minus 3 is equal to 5 times x plus 3. So next we distribute. Negative 4x plus 12 is equal to 5x plus 15. We want to combine our like terms, so I'm going to add 4x to move it to the other side and subtract 15. So 9x is equal to negative 3. What would I do next? Divide by 9. So what does x equal? Awesome. Negative 1/3. Because we could divide our fraction here, top and bottom, by 3. So that gives us negative 1/3. Okay, let's look at number 3. What should I do first to solve? Cross multiply. So we have 1 times 11x plus 8 is equal to x times 2x plus 5. What would I do next? Distribute. So when we distribute the 1, it just stays the same. 11x plus 8 is equal to 2. What is x times 2x? 2x squared plus x times 5 would be 5x. What should I do next? So I can subtract 5x and move it to the other side. And do what else? I can move the 2x squared to the other side. Just be careful because it doesn't have a like term that I can combine with. So I have negative 2x squared plus 6x plus 8 is equal to 0. What should I do next? I could do first times the last, but I can take out the GCF, so I don't have to do first times last. Anytime you have a GCF, you want to take out your GCF. Here, because we have an x squared and an x, we know that we're going to have to factor. So multiplying the first times last is a good option, but whenever you have a GCF, take that out because factoring is going to be a lot easier. So what's my GCF? Negative 2, perfect. We want to take out that negative 2. That way it makes the x squared term a positive one to make it a whole lot easier to factor. So I have x squared minus 3x minus 4 is equal to 0. Now let's see if we can factor. Do we have two factors of negative 4 that add to negative 3? Negative 4 and positive 1. So we got x minus 4 and x plus 1 is equal to 0. What would I do next? Set them equal to 0. So x minus 4 equals 0. X plus 1 is equal to 0. And then we just solve them each. So I would add 4 to both sides. So x is equal to 4. Subtract 1 on both sides. So x is equal to negative 1. So we have two answers here. Okay, the second way that we're going to solve our equations are going to be using the least common denominator. So when a rational equation is not expressed as a proportion, you can solve it by multiplying each side of the equation by the least common denominator of the rational expressions. So we can't cross multiply here because we have two terms on one side. So we can add them together and then solve, or we're going to kind of do it the same way that we did yesterday, where we find the least common denominator and we multiply everything by what's missing, and then we just set the numerators equal to each other because then our denominators are all going to be the same thing. So first we want to factor each denominator. We have three things here that we have to find the least common denominator between. Luckily for us, they're pretty much already factored here because my first one, the only factor is x. So remember, we always have to include the first one. So in my list of least common denominators, moving to the next denominator, I have 4. Do I have 4 on my list already? No, so I have to include it. So I have 4 times x. Then my other denominator, I have x. Do I have x on my list already? Yes. So I don't include it again because I already have it on my list. So kind of similar to what we did yesterday. If it's already on the list, you don't have to rewrite it. So my least common denominator would be 4x. So first step was find the least common denominator. Second step is to multiply the numerators by the missing factors. My least common denominator is 4x, and I have an x in the denominator here. What's missing? 4. So I'm going to multiply the top and the bottom by 4. For the second fraction here, my least common denominator is 4x. I already have a 4 in the denominator, so what's missing? X. So I'm going to multiply the top and the bottom here by x. And then for the third fraction, my least common denominator is 4x. I already have an x, so what's missing? So we'll multiply the top and the bottom by 4. So if I were to rewrite this, I'm going to multiply each pair together. So I have 20 over 4x plus 7x over 4x is equal to negative 36 over 4x. Once we're here, once we get all of our denominators to be the same, we could add it together and then cross multiply, but because our denominators are the same, they're going to end up canceling out. So what we can do is just set all of our numerators equal to each other. So whenever our denominators are all the same, we just set the numerators equal. So I have 20 plus 7x is equal to negative 36. We get rid of the whole denominator. So we only care about the numerators. So everything with the numerators stays the same. The denominators just go away. So we get rid of the fractions. And then from here, we would just solve. So I can subtract 20 on both sides. So 7x is equal to negative 56. What's the last step? Divide by 7. So what would we get? X is equal to negative 8. Awesome. Okay, let's take a look at the next one. So the next one, we're doing the same thing. We want to make all of our denominators the same so we can just cancel it out. What's my denominator for that 1 that we have out front? 1. We could just call it 1 over 1. So let's find our least common denominator. Well, we have x minus 5 as a factor and x. Do I have anything in common between 1, x minus 5, and x? So what do you think our least common denominator is going to be? Remember, we have to just list them all. So we have x and x minus 5. Multiplying it by 1 doesn't change anything. Because there's no overlap, there's nothing in common, we don't need to exclude anything from our list for our least common denominator. So now we multiply the numerators by the missing factors. So for 1, with my denominator being 1, what's missing? X and x minus 5. So I have to multiply this 1 times x and x minus 5. Now for our next fraction, we have x minus 5 as our denominator. So what's missing? Just the x. So I only have to multiply by the x. And then in the third one, I have x as the denominator, so what's missing? X minus 5. So now we multiply the numerators together. Not all together, but we multiply by the factors. So 1 times x minus 5 would just be x times x minus 5. And be careful here, because we're subtracting, it's a negative 8, so that would be negative 8x. And that's equal to 3 times x minus 5. What should I do next? Distribute. So I'm going to distribute that x, and then I can distribute the 3. So it gives me x squared minus 5x minus 8x is equal to 3x minus 15. Then what would we do? Combine like terms. So I have like terms on this side that I can combine. So that would give me x squared minus 13x is equal to 3x minus 15. I'm going to move everything on one side because I have an x squared and an x. So what does that mean I'm going to have to do? I'm going to have to factor. So I need to make it equal to 0 because I'm going to have to factor. So I'm going to move that 3x to the other side and the 15. So x squared minus 16x plus 15 is equal to 0. All right. What are two factors of 15 that add to negative 16? negative 15 and negative 1. So here we have x minus 15 and x minus 1 is equal to 0. Now we have to solve all the way. We're not just stopping at factoring. So what would I do next? Set them both equal to 0. So x minus 15 is equal to 0 and x minus 1 is equal to 0. So we add 15 to both sides and add 1. So x is equal to what? 15 and 1. Let's do number 6. So what's the first thing I should do? Find the least common denominator. My denominator for the first fraction is x plus 1. So I have to include that on my list, x plus 1. Can I factor the second denominator? How does it factor? It's the difference of squares, so what would it factor into? X minus 1 and x plus 1. So when I include my factors in my least common factor here, my least common denominator, what would I have to include? Just x minus 1, because I already have an x plus 1 on the list, so I don't have to repeat it. What's my denominator for 3? 1. Do I have to put 1 on my list of denominators? No. What's the next step? I got to multiply the numerators by the missing factors. So what am I going to multiply the first fraction by? X minus 1. What about the second fraction? Does it have anything missing? It's got an x minus 1 and an x plus 1 in it, which are both of my factors here. So it's not missing anything, so I don't have to multiply that one. What about the third fraction, 3 over 1? X plus 1 and x minus 1. So we got to multiply them together and then add it all together. How would I multiply 4x plus 1 times x minus 1? Distribute, but since they're both binomials, what do I do? FOIL. So we're going to multiply the first ones. What's 4x times x? 4x squared. The outsides would be minus 4x. The insides would be plus x. And then the last would be minus 1. And that's equal to 12 plus, I have to multiply all 3 of these together so I could FOIL these back out. What am I going to get when I FOIL these two together? X squared minus 1. Because I already factored it, so I know when I multiply it back out, it's going to give me x squared minus 1. So this is the same thing as saying x squared minus 1. And then I just have to distribute the 3 to that. So it'll be 3x squared minus 3. What's next? Combine like terms. I see that I have an x squared and an x, so what do I know that I'm going to have to do? I'm going to have to factor, so I'm just going to move everything to one side also. So here, I'm going to kind of do a couple steps at once. I'm going to combine my like terms and move everything. So I'm going to subtract 3x squared to move that to the other side. What's 12 minus 3? 9. So I'm also going to subtract 9 because this is the same thing as saying 9. So I'm going to subtract 9 and move it to the other side. And then I'm going to combine negative 4x plus x. What's negative 4x plus x? Negative 3x. So I'm going to combine my like terms now. So I have 4x squared minus 3x squared would be x squared minus 3x minus 10 because I had a negative 1 minus 9. What would I do next? Factor. Do we have two factors of negative 10 that add to negative 3? Negative 5 and 2. So this factors into x minus 5 and x plus 2. What's next? Set them equal to 0 and solve. So x minus 5 is equal to 0 and x plus 2 is equal to 0. So x is equal to positive 5 and negative 2. So example 4 says solve an equation with an extraneous solution. So anytime it says extraneous solution, it kind of tells us that one of our answers may not work. So this just means that we have to check the answers. Now, we're dealing with fractions here. So what type of answer do you think would mean that it didn't work? Why are we checking? What do we have to check for? We don't have square roots. Decimals would be okay. We can have negatives in a fraction. What could we not have in a fraction? We can't have the denominator be equal to what? 0. Denominator can't be 0. We can't have a fraction that's 1 over 0. This is undefined. So we have to just check and see if we plug our answer back in and it gives us 0 in the denominator, it's not going to work. So we have to check the answers because we can't have the denominator be equal to 0. All right, so let's solve it the same way we did before. What do I have to do first? Least common denominator. So that means I have to factor each one of these. So x minus 3 is already a factor, so we're good there. How would I factor x squared minus 9? X plus 3 and x minus 3. And then x plus 3 is already a factor there too. So what would my least common denominator be? X minus 3 and x plus 3. Perfect. Because if I include this x minus 3, I don't have to include it here again, but I do have to include the x plus 3. But then I have another x plus 3, so I don't have to put that. So in my least common denominator, everything's accounted for there. What do I do next? Multiply by the missing factors. So what's missing from the first one? X plus 3, perfect. So I'm going to multiply this by x plus 3. What's missing in the second one? Nothing. So we can leave that. What's missing in the third? X minus 3. So we're going to only be dealing with our numerators now. So how would I multiply 6 times x plus 3? Distribute, so that gives me 6x plus 18 is equal to 8x squared. Then here, be careful, because we have that negative, so it's negative 4x. How do I multiply negative 4x times x minus 3? I got to distribute. So negative 4x times x is negative 4x squared, and negative 4x times negative 3, 12x, positive 12x. What would I do next? Add like terms. So 8x squared minus 4x squared would be 4x squared. I can subtract the 6x to move it to the other side and subtract the 18. Just be super careful with your combining like terms. Remember, if you're moving it to the other side, you got to do the opposite. So here, 12x minus 6x is 6x minus 18. What can I do next? What's the GCF? 2. So I'm going to divide everything by 2. So we have 0 is equal to 2x squared plus 3x minus 9. So we took out the GCF, but we still didn't quite get our coefficient in front of the x squared to be 1. So how would I factor from here? First times the last. So 2 times negative 9, negative 18. Do we have two factors of negative 18 that add to positive 3? 6 and negative 3. Awesome. So here I have x plus 6 and x minus 3. What do I have to remember to do when I start by multiplying? I have to divide by that 2 out front. So whatever we started, when we multiply the first times the last, we have to make sure we go back in and divide the first. Simplify your fraction if you can. So we have x plus 3. What happens if I can't simplify it? Put it in front of the x. So 2x minus 3. You guys are like professionals at factoring now. What would I do next? Make them both equal to 0. So x plus 3 is equal to 0. 2x minus 3 is equal to 0. And we just solve both for x. So x is equal to negative 3. For the second one, we have to add 3 to both sides and divide by 2. So x is equal to 3 over 2. Now, what did it say in the beginning? Check for extraneous solutions. So I have to plug in my answers to see which one is going to give me 0 in the denominator. Which one, if either one. So let's plug in negative 3. So I'm just plugging it into the denominator. We don't have to plug it into the whole thing and make sure it works out. We know that these answers are going to work out. We are just plugging it into the denominator to see if we get 0 in the denominator. What's negative 3 minus 3? Negative 6. So it's not 0, so we're good there. Let's plug it into the next one. We have negative 3 squared minus 9. What's negative 3 squared? 9. And 9 minus 9? 0. Can I have 0 in the denominator? So what does that tell me about negative 3? Doesn't work. You could also check in the last one too. If we plugged in negative 3 here, negative 3 plus 3 is what? 0, which tells us again it doesn't work. We can plug in 3 over 2 also. But just by looking at it, we can kind of tell that 3 over 2 is going to work, because if we subtract 3 over 2 by 3, does that give us 0? No. If we square it and then subtract 9, that's not going to be 0 either. Or 3 over 2 plus 3 is not 0 either. So 3 over 2 works. So you just have to see where it gives you 0 in the denominator. That means it's not going to work. So our only answer here is 3 over 2.